All right, so welcome back again to another episode. In this one, we'll be talking about the bucket sorting algorithm. So, as always, first we'll take a look at the theoreticals and then we'll move on to the practicals. So, inside the theoreticals, we'll have the definition, then we'll have the steps of how we exactly perform the bucket sort algorithm, and then we'll have the advantages and disadvantages. And once we're done with that, we will be packing up. That's it. All right, so let's just start with the definition of it and understand what exactly is bucket sort algorithm. So let's just get to it. So basically, bucket sort is a distribution-based sorting algorithm. It's not like the other sorting algorithms, not no comparison-based algorithm, no simple algorithm, no sorting algorithm, no swapping algorithm. It's distribution-based sorting algorithm. It creates multiple buckets, right? That's why it is called the bucket sort algorithm, right? That sorts elements by dividing them into several groups or buckets and then individually sorting each bucket. So basically what it does is divide an array into different buckets. Maybe there are four, maybe eight, maybe 20, depending upon the size of the array. And then it sorts buckets independently, like entirely each of the bucket is sorted and then the buckets are then further combined. So it is the most effective for uniformly distributed data within a known range. This algorithm can achieve linear time complexity under ideal conditions, making it highly efficient for certain data sets. So, in short terms, bucket sort is kind of a simple and interesting algorithm. So let's just take a look at the steps of performing the bucket sort algorithm. So first, all you have to do is create a bucket, obviously. Then what you do is distribute the elements into buckets. And once you're done with distributing the elements into bucket, sort each bucket one by one or all at the same time, multi-threading. Then what you do is concatenate all the buckets. Now you have all the sorted arrays of all the sorted elements. Combine them. That's it. Sounds interesting and easy, right? So let's just see how much easier it makes for work for us. So let's take a look at the advantages of using the bucket sort algorithm. So the first thing is linear time complexity. Then what else do we have is effective for uniform distribution. Then then it is parallelizable. What does this basically means is parallel sorting. The sorting of individual buckets can be parallelized or parallelized or whatever this word is exactly, making bucket sort suitable for parallel computing environments. Simple as that. Then what else we have is adaptability to different data types. It is like really flexible when it comes to working with integers, floating, point numbers, strings, everything. Then stable sorting because it provides stability. Underlying sorting algorithms uses each bucket is stable. The overall bucket is will be also stable in itself. So let's take a look at the disadvantages because every single light has its own dark. So let us see how many disadvantages this algorithm has got. Okay, space complexity, dependency on input distribution, predefined range, choice of sorting algorithm, complexity of non-uniform data. This is the problem with most of the algorithms, but this one is kind of better and shell will be more better. So these are the advantages and disadvantages and also the steps of performing the bucket sort algorithm. So let's just actually implement it into our coding screen so you can understand it better that how we actually do this stuff. All right. To perform insertion sort, what do we need? We first need insertion sort algorithm to sort the data, and then we use the bucket sort on the insertion sorted stuff because we have to just divide them in the bucket and then use insertion sort on each of them, and that's how we do stuff. That's how the user is going to be working. And at the end, also, I can do that same thing. Mhm. Right. So once you create the while loop, it's simple So insertion sort we have already studied. I'm not going to go deep into like what exactly is insertion sort and how we actually work with the insertion sort because it's kind of constantly. So bucket sort is also kind of not really hard. It's also easier. If the length of the array is equal to 0, then return the array, and if not, then find three things. Find three things: the number of buckets that we have to create, which will be equivalent to the length of the array. Then what else we have to find is the maximum and the minimum value. So all you have to define is just number of buckets and then the maximum and the minimum values. Once you're done with that, now you have to create the buckets and then distribute the elements. So first, let's just create the buckets. Okay, and this is how the buckets are created. Once done with creating buckets, now we can distribute the elements by max value minus min value plus 1 multiply by num buckets. Okay, so once we're done with that, all we have to do is just buckets and buckets of index dot append number. All you do is just create buckets and then save the elements into different buckets. All you have to do is that. Once we're done with that, we'll just do the sorting stuff. So sort each bucket and then concatenate the result. So what we'll basically do is just create an empty array or list. Let's just call it list, which will be called a sorted array, and then just sort all of them and save them. That's it. Once you're done with that, this is basically create our answer, create the list. Sorted array. Inside of that, I'll just simply say bucket sort, and then I'll print the sorted array. I think there is a mistake. Okay, so it's all right. Let's run this again, and you can see there is your output. So this is how the bucket sort algorithm basically simply works. So see you in the next one with some new crazy powerful algorithm. Till then, just keep practicing and keep embracing.